Right. Well, today we're going to be talking about gRPC for PHP developers. It's something that it's not commonly used on PHP Word, right? So the idea here is to give you guys a little bit of a drop. It's going to be a drop in this ocean because there's a lot more to explore. But at least here, the idea is for you to give it to understand a little bit what is gRPC, how can you maybe advantage from it on your next project, or how can you actually go and explore yourself on that topic, right? But just to introduce myself a little bit, I'm Giovanny. I'm the engineer team lead at Worksome, which is a Danish company. You guys can find me on X, Twitter. I don't know how it's called now. But I am a Laravel core contributor, also past PHP core contributor, and Filament PHP also core contributor. I have been talking for the past 2 years, also giving some talks in some Laravel and PHP conference, like some PHP meetups in Portugal, Lisbon, Belgium, and more recently in India on Sunday. So I'm a little bit tired because I just recently arrived yesterday and then fly here to Barcelona. So first, to start understanding this, like how do we make computers talk to each other? Like how do we, when we're building our apps, how do we actually make them talk to each other? Like how do we make our web service talk to each other? So I think if you just answer that, there's one only answer possible, right? With SOAP. Is not? Oh, I don't think so, right? So I think if you give the correct answer right now, it's going to be REST, right? Like everyone uses REST. It's commonly used. Well, you basically don't think anymore when you're creating something. You go directly to REST because, well, it's usually built on top of PHP. You work JSON, which is a text, which is basic text you can read. Human can read what the response are. So it's pretty much it, right? Like I said, it's very easy to understand. It's a text protocol. It's built on top of HTTP. Currently, there's a lot of great tools already for building, testing, for inspections, for debugging. It's very fast. It's very easy, right? And well, it's very decent in every language. Like it's very high implemented in every language, right? But there's a lot of steps that you need to follow to implement REST, right? Or to use REST. So basically you need to, well, when you're doing a REST call, you need to open the request, the connection to the server, and then you need to, well, build your call to the server to send your HTTP request. And then of course you're gonna build it, you're gonna select the method, you need to build the body, of course, and then you need to wait for your response from the server, and then you need to cross your fingers and wait for the 200 status response, right? And then of course you need to parse that response and then check for errors. There's a lot of steps you actually need to follow, right? And there's one big piece of this that if you don't have this, you cannot work with REST, which is basically the documentation, right? So if you don't know what the endpoint is expecting, or at least what is going to send you back, but mostly what it's expecting, you cannot use a REST API, basically, right? There's no way you can actually see how things works. And then, of course, you see on situations like this, like especially with dates, like how many times you were like trying to use it and you don't have the correct documentation. How the heck that date format works, right? But it depends on how you look at it, right? Because maybe the API can have a bug if you don't have the documentation, right? So it's very challenging, right? When you have this word of REST, of where we have a lot of service running on the back end, and you need to have documentations full of that. You need to keep this documentation updated, and you probably end up with a lot of tech debt, right? On a lot of those, and then if you update something and you don't update your front end, it's suddenly you have an error and things like that. So it's quite challenging. We are used to it. That's true because, well, it's what we do, right? But if you think correctly, it's stressful sometimes to keep going on this, right? And there's one thing that's more challenging yet. It's that on the back end, it's very common that you don't have the same language, right? You actually have microservice. And those microservices actually use it like everywhere. right? And with different types of language sometimes, depending on how your architecture is structured, right? And that's here on the back end where the gRPC can help us pretty much. Like, it's not, I would say that it's not an interface that it's mainly used for the communication between your front end and your main back end, but it is very helpful if you need to communicate between computers, like between the microservice, right? So that's where we're gonna be trying to focus here. So let's try to understand what this gRPC is. So as a standard, gRPC, it's a remote procedure call. It was created by Google, so the G, it's basically by Google, right? So Google remote procedure call. And basically, essentially, if we define in one phrase, it's gonna be like data exchanged between two process, right? So it's basically two computers exchanging data. And we're gonna understand why this is very efficient comparing to a REST API, right? While in REST, you have like this types of, it's a URL, like this URL structure where you're having the users and you're calling, for example, the ID, post ID. That's very standard, right? On gRPC, we actually don't have like a URL call. We have actually functions, right? So essentially, if you think of it, you're not doing like an HTTP request. You're actually calling a function in another server, in another computer, right? As it was local. So that's difficult for us, especially for as a PHP developers to put in our minds, but essentially is that. When you have a gRPC server running and then your client in gRPC, it's actually calling a function as local. If you simplify, it's gonna be almost like that, right? So when to use it, like gRPC, right? If I say that it's not like from the front end to the back end, etc., when actually it's good for us to use it. Trying to simplify, gRPC is very good for actions. Like if you need to do some heavy lifting process in your between microservice, and like forget about CRUD. This is REST. Like keep using REST for CRUD, like creating, delete those resources. That's perfect fine. But you need to do some heavy lifting, like for example, chat application. We could actually do something like that using gRPC, right? And why actually using it? Well, HTTP2. It's built on top of the HTTP2. So that's a very big gain already when you talk about it. And it's language agnostic, right? We're gonna see here how we actually do it and how we actually work with it. So with one single definition, which we could call our documentation, you can basically run clients and servers in many different languages. So it's not it's not attached to one single language. So that whole mess that we can see here on the back end, you don't need to actually understand what language is one microservice, what other language to other microservices. You can just run it between definitions, right? It's highly efficient and it's scalable. Why? Not just because you use the HTTP2, but also it's because it's binary. So remember when you use like JSON with REST, right, or XML, whatever, it's actually text, right? We're actually sending text and receiving text. So that's very heavy for the service to do, for the servers to do. So, and with gRPC, it's basically binary. So, of course, there's some downsides that we can talk later. But like for example, debugging is way more difficult because you don't have this human factor of being able to read something from it. But it's very efficient because of it, because it's basically and it can handle, of course, large amounts of data because of that, right? You can just send. If any of you actually use Google APIs, some of the Google APIs already use gRPC by default. And for example, the Google Ads API, and where you can ask for a lot of data, by default, it's going to work way better with gRPC, just because there's a lot of information that you can pull very easily, right? And for those that never work or doesn't know the concept of HTTP2, well, like I said, it's binary, so it's very easy to work with, multiplexed. So you can use the same connection for exchange data. So it's very straightforward on that. So if you compare, it's going to be like this. Like with HTTP1, we already know. We send if we need, if you were open your page and you need to load one CSS, one JavaScript, it's one request per each file you're requesting, right? But with HTTP1, HTTP2, you just do one request, receive everything. So if you ask and compare as yourself in a restaurant, it's going to be just like that. Imagine asking your waiters to go there every time for one single request, while you can ask for everything at once, right? So it's the idea. So yeah, that's another exemplification on how that actually can work on HTTP2, right? That's why it's very scalable. So who is actually using gRPC already? Big companies, right? Google, Netflix, Docker, Square, Core, S2H, all those guys already using gRPC in so many different languages, because it supports a lot of different languages, right? Okay, so we understood a little bit about what gRPC are, but there's another part of this that we need to understand, another concept that we need to understand, which is this guy here, is protobuf, right? Protobuf, it's the definition. It's basically as if you're going to compare the documentation, right, of your API, the what you're working on. And the good thing about protobuf is that it's code, so you can versioning, you can roll back if you need it. So it's just there, like, and it's agnostic. It's one definition. All the language is going to understand that, and it's going to make the things way easier. So those are the two concepts that we need to understand today. So gRPC that's the protocol, while the protobuf is the definition of the service message that's going to be exchanged. So PHP doesn't need to understand how the response is going to be like, and Go doesn't need to understand how the request is going to be like, because they have this contract between, which is the protobuf, that's going to be, okay, if I want to send a request and receive a response, you have this contract that tells me how it's going to be. It's going to be one string, one integer, and etc. Right? Yeah, cool. Let's go here and about an example. Yeah, let's go through the example here on the slides, and then maybe I can show a little bit the code, how generated. But yeah, what we need to do for this example, what we're going to see on this example here, we're going to see a definition, a protocol buffer definition. That's the first thing we're going to do. We're going to need. Then we need this proto-C locally for generate the client and the server stubs based on this definition that I just gave, right? And then we need, of course, the gRPC server to handle the request. We're gonna try to focus here on those two, just because the server in PHP, gRPC server in PHP is not default supported. We're gonna see that there's a way to do it, but by definition, it's not default supported as we use PHP or with an Nginx today, right? Yeah, so basically, that's the workflow of working with gRPC. You have your protobuf definition. That's the documentation I just told. We're going to write down everything that our API needs to do. We're going to run that through a proto-C compile, and we can generate as in different languages the clients that can be used, right? And also, if I want to, the servers that I need to use it. So the first step here is to create the proto file. Like I said, the definition. That's an example. First thing here is the syntax. We're gonna just define that using the proto-C, the proto3 syntax already. In this meetup, we're gonna have an after party, so we're gonna call this package after party. And on after party, I have one service, right? And this server is to get a beer. I want to get a beer. To do that, I need to send a beer request, and I'm gonna receive a beer response, right? So, and now this is my documentation, right? It's how it almost looks like I'm writing a documentation for my API. So I'm saying that I have one function, which is the get beer, and I have those two definitions here. First one, it's a beer request, which receive a word, right? I hope that word is please, right? Please give me beer. and then the response, which is hopefully a pint of beer, right? So I have those definitions here. So it's almost like I'm defining here, like I always try to compare, like we're giving like the JSON that's going to be the request and the JSON that's going to be the response, but as a definition of typing, right? Yeah, after I have this, I'm going to save this proto file. I'm going to run this, and like we're focused on the PHP client, I'm going to run this with the proto-C compiler that I already have installed on my machine, and I'm going to run this, and I'm going to say that I want that the proto-C compile, I want to see a PHP. I wanted the PHP to be saved on the lib folder, right? I'm going to say that the gRPC server is going to be also outputted to the lib folder. I'm going to use the plugin, which is the gRPC PHP plugin, right, to it. It's already installed. And I'm going to give the name of my proto file definition. That's the only thing you need to do, right? I did the definition of my API with all all I want to do, all the functions I want to call, all the messages I want to exchange. I run to this compile, and it's going to generate for me the client that I can use, right? Let me just show here how those files look. Is that way? Is that way? Yeah. Oh, so that's, like I said, the proto file that I just showed, which is the same, right? It's just the proto file. I run that, and okay, it's not here. So let's run the command. I already have here on my notes. Let's copy this command. I'm going to run this here. Just by running that, I have here now the two folders. The afterpart client, for example, it's a PHP generated. So basically, we're going to have here the function get beer, right? It's going to receive a beer request. If I open here, the beer request is a class with the definition, right? The difference here, you saw on the slide word, but here on the definition of the product, I said please, or that's why it say the please here on the as an attribute, right? And then I have here all the methods already generated for me to, well, get that or set, and I have the response here also generated for me, right? Cool. That's the client one, right? Just get back here to the slides real quick now. Cool. So essentially, that's why you run it through a proto-C. You want to give the flags for the language you want to, so let's say Go or whatever you want to, and then your profile. That's all you need to do, right? After that, you want to generate your gRPC server, right? Like I said, the PHP does not support natively the gRPC service, exactly because we don't have on Nginx, we don't have that HTTP2, using yet. So it's not possible with Apache or Nginx, but it is possible if you use something like the Roadrunner. So if you run your PHP server as a Roadrunner, you can actually do it and run a PHP server, which already have default support. So you need to require on your PHP project, you just run composer require the Roadrunner package, and then there's some classes that you extend on the generated code, and it's going to show you, and you can actually run that through the Roadrunner. It already have a default, it's native default for the server. You can actually run all those languages for now already by default, so if I want to run, if I have my microservices to run, and let's say I want to create a service, I want to give my clients all the different clients to use, I can just run it and generate this with one single command and just having one definition of my API, right? Here I have an example on Laravel project on how you can actually use that generated code on your Laravel project as an example on how we can actually use it, right? So I generated that from my definition. I generated that classes. I can put that on a package, for example. I can import that here locally, but you can do it this via a version controlling or via Composer private or wherever you want. So I just importing this here. And then let's say that I have a beer controller on my application where the user is going to click a button to get the beer, right? So what I'm going to do, and what I'm doing here is just I'm importing, right, my client that I just created, and then I'm initiating my client here using whereas my server is running, right? The server that is not creating PHP in this example can be created in a different language. I'm going to give the server here URL, and then inside my controller here, I am just initiating a new beer request, which is basically initiating the class that we just saw. I'm going to set in the word please, right? And then I'm going to list and listen for the request back, right? So I'm using here. So if we analyze this from the definition of the proto file, we have here the service that I created, which is the function that I'm calling on my server, which is the get beer, right? Which receives a request, which is basically a class defined with the structure of that class defined on my proto file. And then when I receive the response, I already know that I can get the pint because the pint is defined on my proto file as well, right? So that's essentially on how can you work basically with gRPC and proto files, right? I think that's what I had to share today with you guys about this word of gRPC and proto files. I hope that starts taking something for you guys to go and search more a little bit about it. And yeah, hope to answer some questions. If not, yeah, cool. Thank you.